Oh, here we go. First day of CCNA4, first chapter at least. Okay, so this chapter is basically on the certification CCDP, and they're just giving you a real brief go over of it. So at the end of this one, we're going to describe the structured engineering principles for network design, describe the 3 layers of a hierarchical network and how they're used in network design, describe the various modules in network design, describe Cisco Enterprise Architecture model, describe the need for business network architectures that are designed to address emerging trends in IT, describe 3 business network architectures: borderless network architecture, collaboration network architecture, and data center virtualization network architecture. Okay, so these are kind of designs and kind of branding. Basically, this is the 3-tiered design we've talked about before. We're just going to be going over design more. Alright, so our 3 layers in our 3 layer design hierarchy is access, distribution, and core, but I'm sure this is not our our chapter yet. Okay, so this is what we're going to look at. Sites like this. Okay, so first you're going to need to know what determines a small, a medium, or a large network. Alright, so a small network provides service for up to 200. Medium is 200 to 1,000, and large is over 1,000. So most of our networks in the surrounding area are probably 200 to 1,000 devices, if not small. Okay, so when we go into here we have our main site, right? And right here, this is what we would call the core, and there's more than one switch there. We have more than one device doing this, and the core feeds out to these distribution switches. That's a distribution switch, that's one, that's one, that's one. That's what he's actually hitting. And then we have these access switches that are powering the devices. Okay, that's our 3 layers in there. Alright, so that's that explained already. We're going to be going over that more, but that's that. Then we have our WAN connections. So these, when we say WAN, and we're going to this site, this WAN connection is something like a T1, an OC1, which is fiber or telephone, right? So a WAN is a private line, or it's an MPLS circuit. Then we have PSTN, which is public switch telephone network, and so this is where we're going. I don't know, ISDN. I guess we could be doing T1 there as well, something like that. And then we have the internet. So this is our Metro Ethernet cable or DSL. We're going to have a VPN, like this firewall, connecting us there, going here. Stuff over here is probably our e-commerce modules, that kind of thing. But anyways, these are all connecting remote sites, and then we're seeing what they're doing. You know, we have the remote large site, remote medium site, and the remote small site. It's strange they all have data centers, but hey, I guess if they're big enough, they need a little bit of a data center. Normally we could just connect back to our own or go into the cloud. Anyways, so that's what we're going to be breaking down. Alright, so why do we care about any of this chapter? Well, it's teaching us how to design, and we're going to design a network for hierarchy, modularity, resilience, and flexibility. Alright, so hierarchy. A hierarchical network model is useful for high-level tool for design. Is a useful high-level tool for designing a reliable network infrastructure. It breaks the complex problem of network design into smaller and more manageable areas. Modular. By separating the various functions that exist on a network into modules, the network is easier to design. Okay, so we're gonna probably hate modules by the end of this chapter. But anyways, there's modules such as Enterprise Campus, Services Block, Data Center, and the Internet Edge. Then we want it resiliency. The network must remain available. Remember, we're looking for 9.999, 4 nines behind the 99% uptime. Normal conditions include both normal or expected traffic flows and pattern flows, as well as scheduled events such as maintenance windows. Abnormal conditions include hardware or software failures, extreme traffic loads, unusual traffic patterns, denial of service events, and whether intentional or unintentional. Oh, that's with the DOS. And other unplanned events. So we want it to be able to survive all those things. Flexibility, the ability to modify portions of the network, add new services, or increase capacity without going through a major forklift upgrade, i.e. replacing major hardware devices. Alright, so we go back to our layer design where we have access, right? So this is where our endpoints are, provides workgroup user access to the network. Distribution provides policy-based connectivity and controls the boundary between the access and core layers, and then the core layer just provides fast transport between distribution switches within the enterprise campus. Alright, so if we don't have that, we have this flat thing. And so flat means we can't expand, we are going to fail, and so flat was just that before. So any failure and we're done. And so this end thing is showing us how we make it hierarchical rather than flat, right? And what it's showing here is in the middle here we have the core. Oops, it's not a very straight line. Alright, so we have the core right here. So this core is just, its only job is to do high-speed switching between these buildings. And sometimes we have a tier design called collapse core where we don't even have this. It's been talked about in the past. Anyways, the core, just fast switching. Then the distribution, it's doing all kinds of stuff. It's doing the routing, it's doing the ACLs, it's doing all of our layer 3 stuff, and it might be going layer 2 to here, but it might be doing layer 3 all the way down to the access as well. And so it's busy. It's real busy. Then we have our access layer, which all of our endpoints connect into. So we're talking about stuff like PoE and, I don't know, layer 2 security, that kind of thing, MAC addresses. And so as we go through, we're going to find out even more about it. Alright, so what's happening at the layer 2? It might, okay, this is not a guarantee, it might be layer 2 switching, because with the cost of switches, layer 3 switches going down, we can get a 2960X that supports layer 3 for the same price as a layer 2 switch. So it doesn't necessarily have to be, we can go layer 3 all the way down to the access, but typically layer 2 switching in older networks. High availability, well, if we shut down where our access points go, nobody's getting on the internet. So that's basically what that's saying. Port security, that's that layer 2 security where we're filtering on max. QoS and marking trust boundaries. Okay, so probably our QoS here would be layer 2 QoS, where we classify it at the layer 2. Address resolution protocol, well, ARP's going to hit there because this is where our VLANs are, right? So ARP's going to be in between each VLAN. We have VLAN access control list, and we have spanning tree running because it's layer 2, so we have to stop the layer 2 loops. And we have PoE and auxiliary VLANs for VoIP, okay? And notice all of our end devices are connecting there. Then we go to our distribution, okay? Aggregation of the LAN or WAN links. So they're going to connect into here. Policy-based security in the form of access control lists and filtering. Routing services between LANs and VLANs, between routing domains. Okay, so we're using our Azure and OSPF are going to run in our distribution. Redundancy and load balancing. What that means is probably our port channels are happening in here. This is not a port channel. This is a virtual stack, switch stack, a VSS. So where these two devices are actually simulating each other, or they're stacking each other through 10 gig links. We need a boundary route for aggregation and summarization configured on the interfaces towards the core, right? So we're going to keep the core data. We're going to summarize our routes to the core. That's basically what it's saying. And broadcast domain control, because routers or multi-layer switches do not forward broadcast. The devices act as the declamation point between broadcast domains. and what the D mark means is just the stop of the responsibility. Okay, so finally, we have our core, providing high-speed switching, providing reliability and fault tolerance, scaling by using faster and not more equipment, avoiding CPU-intense packets, manipulation caused by security inspection, and quality of service, classification, or other processes. Alright, so all these CPUs in these 6509s are going to connect with lots of fast, probably 10 gig, maybe 40 gig links, and they're going to connect to each other and just be super fast switching, no routing, probably, just because that's taking up too much CPU. If we are doing routing, we're being real careful. Alright, so that's our core. So then, when in a smaller environment, which usually they say 5 if we have less than 5 sites, we use this collapsed core. I don't see it right here, but all it means is instead of separating out the core, the distribution layer does both the job of the core and of the distribution layer. So we have an access layer and a distribution, or we have an access layer and a collapsed core. So it's two-tiered. Go ahead and do those. Okay, so then we get into modular design. And so modular design breaks, when we're designing it, we can break it into modules such as campus, data center, teleworker, and branch. Those aren't the names we're going to be using, but it helps us build these better, I guess. I don't know what else to say about that. But, yeah. So basically, it's just breaking them into functions. So some of the functions we can break them into, or some of the benefits of using modules. Failures that occur within a module can be isolated from the remainder of the network, providing for simpler problems, such as our teleworker. If it goes down, well, just the people with the VPNs can't do stuff, but in this sense, I guess our branch sites, either using WAN connections, it looks like they're probably using VPNs, but their VPNs work, the teleworker module does not, so everybody's still up and running besides the guys off-site. Network changes, upgrades, or introductions of new services can be made in a controlled and staged fashion. I think you guys can get the gist of that. When a specific module no longer has sufficient capacity or is missing new function or service, it can be updated or replaced by another module that has the same structure or overall role. Security can be implemented on a modular basis, allowing for more granular security control. Alright, so our modules. We have the access and distribution module, the services module, data center, WAN edge, internet edge. That's not what we're going to be learning about. As far as I know. But let's talk about them. So also called the distribution block. This is the most familiar element, fundamental component of a campus design. This is generic services, general block to identify services such as lightweight access point protocols with wireless controllers, unified communication services. Unified communications means VoIP and video, policy gateways, and more. Data center, originally called the server farm. This block is responsible for managing and maintaining many data systems that are vital to modern business operations. Employees, partners, and customers rely on data and resources in the data center to effectively create, collaborate, and interact. The enterprise edge consists of the internet edge and the WAN edge. These blocks offer connectivity to voice, video, data services outside of the enterprise. Neat. Alright. So Cisco Enterprise Architecture. These are the ones we care about. We're going to be tested on those. Thank goodness probably only in this test, unless you guys decide to do a Cisco Design Professional Design Associate. And that's what the whole test, I don't know, about 60% of the test is on this. Just in depth. Okay, so here we go. We have our Enterprise Campus, Enterprise Edge module, Service Provider Edge, and the Remote module. Okay, so what blocks go inside of there? Alright, so our Enterprise Campus, as you guys can see, it's our traditional three tiers that we've been talking about throughout the class with the server farm. Then we have the enterprise edge. Okay, in the blocks in there is e-commerce, right? So all of our sales on the internet connectivity, which is our firewall. As you can see, it feeds into our VPN and access, but our internet connectivity is what's going to connect us to an ISP. I don't know. It's going to be the router connecting us to our internet connections, right? Where e-commerce, this e-commerce, we have redundancy to two ISPs because it's just going to be for sales, and this is showing we have a firewall in there that will be connected, be scanning that, but want to separate those out. Then we have our VPNs feeding into our internet connectivity, right? So they're going to allow people like our teleworker to work over here. Then we have our site-to-site WANs. Okay, so these are our private connections. This is our WAN module, which we have frame relay, ATM, MAN, MPLS, stuff like that. Private lines. These are the ones that are synchronous usually, so they forward at the same rate as they download. Whereas these ISP connections up here, I don't know. This could be Metro Ethernet up here, where we're getting a super fast connection, or here, and probably both download and upload, but not all the time. Our public switch telephone network, this is just our backup emergency connection probably in this sense, but it's connecting these modules. Hopefully I didn't confuse you too much on them. If so, we're going to talk about them anyway. So the Enterprise Campus module consists of the following submodules: building access, building distribution, campus core, data center. Together, they provide high availability through a resilient hierarchical network. And notice, just because it shows two doesn't mean there's two. I just want to stress this, that there's a lot of devices. They integrate IP communications, mobility, advanced security, utilize multicast traffic and QoS to optimize network traffic, provide increased security and flexibility using access management VLANs and IPsec VPNs. Alright, so then we have our enterprise edge. We have our e-commerce networks and servers. The e-commerce submodule enables enterprises to support e-commerce applications through the internet. It uses the high availability designs of data center module. Devices located in the e-commerce submodule include web application and database servers, firewalls and firewall routers, and network intrusion prevention systems. Internet connectivity and demilitarized zones in this. The internet submodule of the Enterprise Edge provides internal users with the secure connectivity to the internet services such as public servers, email, and DNS. Connectivity to one or several internet service providers is also provided. Components of this submodule include firewall routers, internet edge routers, FTP and HTTP servers, SMTP relay servers, that's email if you've forgotten, and DNS servers. Alright, so then we have a remote access and VPN. The VPN remote access submodule of the Enterprise Edge provides remote access termination services, including authentication for remote users and sites. Components of the submodule include firewalls, dial-in access, concentrators, Cisco adaptive security appliances. Okay, so dial-in concentrators, that's just a modem bank, but when we see concentrators, it used to be how people would VPN in. Now we use ASAs to do it. Alright, anyways, and network and IPS appliances, that is just the more advanced ASAs have IPS. The WAN submodule uses various WAN technologies for routing between remote sites and central sites. Enterprise WAN links include technologies such as MPLS, which is multi-protocol label switching, Metro Ethernet, lease lines, synchronous optical network, SONET, and synchronous digital hierarchy, PPP, frame relay, ATM, cable, digital script, basically everything. Alright. Now we have our service provider edge. Okay. I don't know what to tell you here. Okay, it's just the SPN spans across large geographical areas in a cost-effective manner, whatever that means. Converges voice, video, and data services over single IP communications, supports QoS and service level agreements that you have with your ISPs, supports security and using VPNs, IPsec/MPLS over layer 2 and layer 3 WANs. We could have a single home or dual homed ISP. That means 2 or more connections with dual home. Multi-homes means connections to 2 or more ISPs. Dual multi-homes means multiple connections to 2 or more ISPs. Alright, so that's the fun. Enterprise branch. The Enterprise branch module includes remote branches that allow employees to work at non-campus locations. These locations are typically responsible for providing security, telephony, and mobility. Alright, so we have enterprise branches where we form a VPN called a site-to-site VPN. We will talk about that later. We have teleworkers that just use a VPN program to form a VPN from their home. And we have a off-site enterprise that probably is going through our enterprise branch site-to-site VPN, or this could be cloud access or whatever we want. Okay, and that's our modules. IT challenges. Alright, so we have this thing called BYOD, and so this is where you can get the same resources no matter where you go. You bring your tablet or laptop, your phone, and you can access all the server resources just based on who you are. So it puts you in the right VLAN. When you log in, it's not just logging into wireless with a password, it actually puts you there. Online collaboration, this is online meetings, online remote management, all of that stuff, that's online collaboration. Video communication, that's just, yeah, I think it tells itself. And then we have cloud computing. So cloud computing is not cloud storage, once again. This is where we do something from like the Amazon Web Services or Microsoft Azure, and we can actually buy servers that work just like our data center, except we can pick out exactly how many processors we want, how much RAM, and how much storage, and we can run all of our applications in the cloud, and it can either be public, private, or hybrid, but that's conversation for another day. But when we say cloud computing, we're not talking about Google Drive. We are talking about cloud storage sometimes, but typically we're talking about actually having virtual machines running in the cloud, running our applications, giving us, way more uptime and scalability. It's much cheaper to scale in the cloud. We pay a monthly fee rather than buying hundreds of thousands of dollars in equipment. It's changing the world. Alright, so here are Cisco's super fun branding for today. So we have Cisco borderless network architecture. In a nutshell, all this means, I'm sure we're going to go over it, but what it means is you can walk around the network, and anywhere you go, you get networking. So you're on the same network. If you're using your laptop, you walk around and you're on the same VLAN, and or any computer you go to, you can have access to your resources. Kind of thrown in the BYOD there, I would say. Data center, I'm sure you guys understand data center. That's where we're actually just doing virtual machines, high compute, SQL servers, that kind of thing, SQL servers, whatever you want to call it, sitting in a room or in the cloud. Alright, collaboration architecture, this is where we're using, they're probably talking about, I don't know, Cisco's branded messaging system is Jabber, and so Jabber allows you to collaborate wherever. Like you can have a meeting anywhere, and what is their, I can't remember what their big meeting software is they use at the college, but like with Jabber, you hit a button, and so calls to your phone are forwarded to your cell phone. You can make calls from your cell phone, make it look like it's your office phone. And so that's my definition of collaboration. I'm sure they have a better one. So our borderless network Okay, so you guys might actually have to do a drag and drop on some of the stuff, so you might want to take a look at it, right? Cisco AnyConnect is a VPN program that just allows you to work from anywhere. TrustSec, all these are just little branding on these things. Let's see. They are the services. I don't know, like this one. The security is called TrustSec. The mobility is Motion. Application is App Velocity. Multimedia is MediaNet, and energy is EnergyWise, just as this graph says, and that's really all you need to know about it. Unless you are a Cisco partner, then you need to know how to set it up. But mostly they're just throwing some brands out there of stuff they're doing so you can see it. Alright. Collaboration architecture, you can see Cisco telepresence. No, it wasn't telepresence I was looking for. They bought a company, I can't think of it right now. Alright, it's not even here. So, anyways, here's our applications of collaboration services. Take a look at there. Take a look at this collaboration architecture. Probably explains it better than I do. But I don't think it's real important for you right now. So if you do, read it up. So here's a data center. What is our data center powering? Apparently unified management, unified fabric, and unified computing. Or these are actually what we're doing in the data center. So unified management means simplify and automate the process of deploying IT infrastructure. This one's been huge. They now call this, I believe, Hyperflex would be their unified management, and it's where you can deploy lots and lots of servers extremely fast. You just plug them in, and they're basically up and running as soon as you plug in a new appliance. Our unified fabric is flexible network solutions deliver network services to servers, storage, and applications, providing transparent convergence, scalability, and sophisticated intelligence. Solutions include Cisco Nexus switches, Catalyst switches, Cisco Fabric Manager, and Cisco NXOS software. Unified computing, Cisco's next generation data center systems units, computing, network storage, access, and virtualization into a cohesive system designed to reduce total cost of ownership and increase business agility. The Cisco Unified Computing System, Cisco UCS, is built with blade servers, rack mount servers, fabric interconnects, and virtual interfaces. And so what this is called is, usually we call this a converged network or a hyper-converged network. It depends what we're doing. And what it just means is we have an appliance and we plug it in, and it has it has a switch built in, it has servers built in, and it's expandable, so we can put more servers in. So what is there? Buy as you grow. Yeah, buy as you grow is what they call it, I believe. Anyways, but so all this stuff's built in. We put it in, and that's what the UCS, the Cisco UCS is. It's very cool, very, very cool. It's also very expensive, but take a look at it. Expanding the network. This is just talking about how we need to have the ability to grow and expand, and that's what this whole what is this? This CCNA4 is called connecting networks. So basically everything we talk about is based on the internet, connecting different sites, now that we know how to build them perfectly because of CCNA3. Okay. You might want to do these activities just as you are. I know they have some weird stuff on the test. Oh, look at this. OSPF Skills Challenge. Probably should do this just to refresh your knowledge on OSPF. And why don't you hit the EIGRP while we go? Okay, it's saying, hey, that stuff's not going away. Even though we're not studying it, we're going on WAN level stuff, but you're still going to need to know it. Alright, so that was chapter 1. I hope you enjoyed it. If you have any questions,